Alright, we have another one that involves the trig functions with parametrics. So let's do the same thing we did before for the previous example. We're going to take the values for t, put them into each of these. We have our unit circle up here as a guide. We can put in the same values that we had before. So we're going to do 3 cosine of 0. Cosine 0 is 1 from our unit circle, the x-coordinate at 0 degrees. So 3 times 1 is going to give you 3. So the first coordinate is 3. Next we're going to do 3 sine of 0. So sine of 0 is the y value at 0 degrees, that's 0. So you get 0. So 3, 0 is your first coordinate that you have there. Next, we're going to do 3 cosine pi over 2. At pi over 2, the x value at 90 degrees is 0. So 3 times 0 is 0. Then we're going to do 3 sine pi over 2. Sine pi over 2 is the y value at 90 degrees, that's 1. So 3 times 1 is 3. So we have 0, 3 is the next coordinate. Then I have 3 cosine pi. At pi, that's 180 degrees. The x-coordinate there is negative 1. So 3 times negative 1 is negative 3. Then I'm going to do 3 sine of pi, which is the y value at pi. There, so that's going to be 0. So 3 times 0 equals 0 there. So negative 3 comma 0 is the next one. Moving on down, I have 3 cosine 3 pi over 2. That's the x value at 270 degrees, 3 pi over 2. The x-coordinate there is 0. So I have 3 times 0 is 0. And then I have 3 sine 3 pi over 2. That's the y-coordinate at 3 pi over 2, negative 1. So 3 times negative 1 is negative 3. So I have 0, negative 3 there. And then I finally have 2 pi. Now 2 pi is going to be exactly the same values I had before right here. 0 and 2 pi, you're at the same spot in the unit circle. So I get a 1 there for the x value. And if I'm at the y value here, that's 0. So 3 sine of 2 pi is going to be 3 times 0. So you get 0, you should get exactly the same point that you started with. So that's going through, putting in all the values again, using our unit circle here as a guide. So we get this. Now we're going to go ahead and graph it. Now the last time, if you're working with the trig functions, usually if you have trig functions, you're probably going to get a type of an ellipse. That's usually what happens when you have cosine and sine going on there. You have that type of graph. So let's go ahead and check that out in this case. So I have 3, 0. 3, 0 is here. I have a 0, 3. Then I have negative 3 comma 0, which is here. And then I have 0, negative 3 down there, and then it goes back to 3, 0 again. So once again, I have something that's going around counterclockwise. Okay, so I have my arrows indicate the direction of movement. It's going around this way, counterclockwise. Okay, so now we're ready to write the equation for this. Now you might recognize that that's a circle. So we can write the equation for a circle right away. Now suppose you didn't notice it was a circle and we saw this as an ellipse, since we talked about ellipses more recently than you might have talked about circles. Okay, well if we consider that an ellipse, we want an ellipse that's centered at 0, 0, that's opening up, let's suppose it opens up sideways. We use this in this case. Now it actually doesn't really matter which one, because in this case the a and b are both going to be the same. So if you use a squared here or b squared here, it doesn't actually really matter, because the a and the b values are exactly the same on this case. So a circle is a type of ellipse, just that a and b are exactly the same. So either way you write that, you're going to get this, and you get y squared over 3 squared equals 1 there. And you get x squared over 9 plus y squared over 9 equals 1. Now because both these numbers are the same, we can make that actually simpler by multiplying both sides by 9. If we do that, then we get x squared plus y squared equals 9, and that actually is the equation for a circle itself. It's always x squared plus y squared for a circle centered at the origin. And then you have a 9 there. That's the square root of 9 is going to be 3. That's going to be your radius there. So this is going to be the equation for the circle. It's also going to be a type of ellipse. This would be the elliptical formula. And the other way of doing it was what I showed in the previous video. Again, you can solve that for cosine and sine and use the sine squared plus cosine squared equals 1 formula. So again, you can follow the same procedures, but this is probably going to be easier just to read the values directly off of the picture itself. So x squared plus y squared equals 9, that would be the formula if you wanted to eliminate the parameter. We have no t's involved in here, and then this right here would be your graph. It goes counterclockwise.